Passwords are getting out of hand, especially with the need to secure them with length and special characters. The idea came from wanting to use tactile input instead of like dull glass. Simple sensations like this are not easily accessible as they once were. I used parts I really liked: heavy detented switches, the loudest relays I could find, and really stiff switches. When you engage any of these, you can't mess around. You have to be committed. The tactile sensation, the feedback from a cell phone compared to this is just better off left alone. I came up with several ways, but the current working idea is 12 rotary switches, each have 4 positions. So 4 to the 12th power gives us 16,770,216, roughly 16.8 million. There are 4 states for that 16.8 million number, so 16.8 times 4 is roughly 68 million. So this is capable of 68 million different passwords. That seems like a lot, and it is, but that isn't the full capacity of this device. In the simplest mode, it will operate like this, but those 4 banks of 16.8 million can be summed together, not just chosen from. So now we have creating a string of 48 characters long. There are some caveats to this. Passwords would either be 12, 24, 36, or 48 characters long. The unused positions would be set to a null point, which is still sending a character. It's just not part of the string you are remembering. So the actual number for human's sake is a lot less than that 29-digit number. But it's still a lot more than 16.8 million. This front end is using analog voltage, so the simplest way I came up with is to use plus and minus 24 volts. This would give us the 48 positions for all of the rotary switches. There will still be an analog source for all 48 volts. Most likely it will be from a custom wound transformer. I doubt there is a transformer like this off the shelf anywhere now. I have found several places that do custom windings for the transformer, but it will take some time. So far, this is still all analog. The common output on each switch would then pass whatever voltage the switch is currently set at through to the detection side. And the detection side works like this, using a total of 12 channels of analog to digital converting. This will be through common parts like Arduino, Pi, something else similar to that. All this step will do is convert the voltage it detects to a signed ASCII character. As an example, for one of those 48, let's just say -5 volts is changed into a % sign. This will happen sequentially across the rotary knobs once the momentary enter switch is pressed. The last interface essentially is the connection to the computer. Once the momentary enter switch is pressed, each channel is read, 12, 24, 36, 48, whatever it's set to, and each channel is converted to its assigned character. There are 2 capacitors in line with this to delay the momentary enter switch to prevent false entries from tapping the enter switch too quickly. That goes into a buffer that then outputs it to the computer as a generic keyboard entry to wherever the cursor is placed at that time. This would be done serially, but as fast as the computer is capable of accepting inputs. The last real hurdle is the 12-channel to analog converter. This may have to span several devices. Ideally, you would want to have API access to specific websites or programs to enter them directly instead of the intermediate placing the cursor and buffer like delaying. Obviously, this has little practical value. It's more of just a thought experiment that's being executed. As a side note, these are some interesting things I found along the way. This is a 25-pin rotary switch. It has a common 25-pin output that switches between 2 25-pin inputs. So it has 75 points of contact. I can only guess what this was used for, but by far it has the most inputs I've ever seen on a switch. Originally, this was how I was going to do bank switching. I really just wanted to find a way to use it, but now I'm going to save it for something else. Currently, the power supply for all of the LEDs that are installed and yet to be installed are powered by a power supply out of an iMac. This also powers all of the relays as well,